Ladies and gentlemen, hello and welcome back once again to the Inside Analysis Big Data Ecosystem Markets. This is where we talk to all the vendors, or many of them at least, doing innovative stuff in a particular segment. In this case, it's the ecosystem around big data, which, as you can probably imagine, involves just about everything. And today we're going to get to the beating heart of some of the coolest stuff out there these days. These guys really understand what's going on. They're former Yahoo execs. We're going to be talking to Henry Sohn of DataTorrent. So, Henry, let me turn it over to you and let's show us what you got.
Great, thank you. So I'm going to show you here a few demos really of our technology. We are a big data in-memory streaming and real-time ETL platform. And really what that means is that for companies that have to deal with massive amounts of data, not just terabytes of data, but almost really petabytes of data or more, they're really going to need to use technology such as Hadoop to really be able to process that data. And we are a technology that actually sits on top of Hadoop Yarn, the latest version of Hadoop. And we actually work with data as it's coming into the data center and work with that data, process it in real time, in memory, while the data is in motion. And so there's some real changes of implications around what that really means. Here is a demo of what we call our ad demo. And in this particular case, we worked with a customer who was using Hadoop to do batch reporting jobs that were generated once a day. And those jobs told them essentially if they had a business or not. Essentially, they were buying impressions, and then they were being paid by clicks. And so their goal was to try to go out there and get enough impressions and get enough clicks to actually have a positive net margin and make money off of being able to do that correctly. But they didn't actually know if they were succeeding with that goal until the day after the Hadoop job will be run, because there were so many different impressions that they had to analyze and process. So that was a classic Hadoop job, batch process. But that's very difficult to run a business that way, because you could be actually losing quite a bit of money in any given day. So what we did was that we worked with them to build a DataTorrent app that essentially gave them literally a real-time view of all their various different ad programs that were being run to tell them, in fact, if they had a business or not. And so now, as you can see here, there are some key charts that they use. They're looking at cost, they're looking at revenue, they're looking at the number of impressions, the number of clicks, the click-through rate, and of course, the margins. And this is actual data that's being processed and analyzed. And as you can see here, this is currently running at about 10 million events per second. This demo has been running now for about a day and a half, a little over a day and a half, and it's already processed over 1.5 trillion events in that time frame. And this is a real-time chart. This is actually being updated every 5 seconds. You could actually drill down into any specific publisher, and as you can see, the data will change almost instantaneously as a result of that data being kind of specified on. And really, this is the power of the platform, because we're actually making all these calculations simultaneously using a dimensional computing algorithm to come up with this data. And these I'll show you here the console. This console is actually part of our platform, and here you can see this is the actual DAG. So this is the actual application that's running. It's using it's a very simple DAG. It's using 3 different operators. It's an input generator. Then there's the dimensional computing where all the processing is done, and then it's outputting the data into an in-memory database called Redis, where all the charts are being generated from. So really, if you look at the physical DAG view, this is kind of the magic of what we do. We take that logical operator, that logical application, and we essentially instantiate that across the Hadoop cluster. And so, it's a little bit too big here to display all the elements, but we essentially handle all of the jobs and then distribute them across the cluster of nodes that you have in Hadoop. And really, that's kind of the key part of what our platform is able to do. We basically take care of all that plumbing for you underneath. So really, very performant. This particular demo, is done probably on about 4 or 5 nodes. So really, it can handle a ton of traffic. In fact, what I'll show you here next is our machine demo. And in this machine demo, this one is a highly performant demo. As you can see, this is now running at close to 500 million events per second. It's been running for now really just about an hour, and in that hour, we're already at almost close to 2 trillion events. So really, in this demo, we have a customer that has thousands of devices out in the field, and those devices are reporting health information back to the mothership, essentially. And really, what this allows the customer to do is, because they're being able to track this data in real time, they can actually get alerted to various different outages or problems that are out in the field, and do some predictive analytics, and in fact, take proactive steps before it spreads out across their entire installed base, and push out various updates if necessary to the firmware, things of that sort, and really just do just tremendous amount of proactive support, so that the customer's downtime is in fact minimized. So this demo, actually, what we did previously was we wanted to kind of see what our total throughput was for our platform. So we took all our other demos off, we took everything, and really just kind of maxed this demo out as far as we could. We actually have throttled this demo now. And we were able to achieve about 1.6 billion events per second. And this cluster is a 35-node cluster that's about 4 years old. The hardware is about 4 years old. So our platform, clearly is very performant and very interesting. Here's the actual logical view of the application that we're using here. This is a little bit more of a complex application. It's got 6 different operators, what we call operators. We've actually already open sourced 400 operators to date, so that customers in many cases can just simply take the existing operators and just simply connect them into a DAG, what we call a DAG, a directed acyclic graph, and that becomes their app. And this is the actual logical view of that app. The physical DAG view here, this is going to, I don't think there's any way to actually show this all on a single screen, but it's, this is quite a large app, so it's basically exploding out this app quite a bit to be able to handle all the processing on all the computations. Quite a bit of computing here. But that's really kind of an overview of our scale, right? What I want to show you here next is what we call our Twitter demo. And so we took the full Twitter fire hose, and you can see here that full Twitter fire hose on a normal day is actually not that large, right? I mean, it's about, in this case, it's about 10,000 events per second. So on a regular basis, they don't, it's not really big data in that sense. It's not anywhere near the kind of transactions that in some of these other cases that we're working with. But for the purpose of this demo, we thought it'd be interesting to show you this. So here, what we're doing is we're showing you a chart of the top 10 hashtags that are currently being tweeted out across the Twitterverse. Currently, this is being updated every second, essentially. And what I wanted to show you here is sort of an example of our fault tolerance. Here, this is the actual DAG. This is a linear DAG in this case, and fairly simple. We're taking the tweet sampler. We're extracting the hashtags using the hashtag extractor. We're then counting the unique hashtags. We're then putting them into a count and then ordering them by volume. And so essentially, what you see here is the physical view. I'll go to the physical view, and I'm going to go ahead and kill one of the operators here, one of the nodes, and show you how we handle node outages. Now, I'm going to actually describe what you'll see because it's going to happen fairly quickly, and so you may not really notice what's happening. I'm going to go ahead and kill this operator here, the unique hashtag counter. It's currently operating on node 24 on our cluster. And what you'll see when I kill that node is it's going to send all this operator and then the downstream operators into a pending state while it's waiting. And it's going to then ask for a new resource, a new node, get that new resource within about a second or two. And then from that one new resource, it's going to then recover from that outage within about 2 or 3 seconds. And while it's recovering, the events per second will probably spike up to about 12 to 15,000 events per second, but then after about a second, it's going to get back down to steady state. And we handle that node outage with no data loss and no human intervention. So that literally by the time that someone has been alerted that a node is out, we've recovered from that outage and back to steady state within about 2 or 3 seconds. And we can do that because we have fault tolerance built into our platform. We use a process, what we call checkpointing, essentially, where we checkpoint the state of the entire system every 30 seconds, so that anytime a node goes out, we can actually rewind the data back to the last checkpointed state and reprocess all that data from that point, and then get back to a steady state again without any data loss, and all the calculations will remain. And that's going to be important because whenever you're doing stream processing, whenever you're doing creating calculations, even if you're doing a simple count, if you lose data, then that calculation is completely wrong. And so it's critical in that whenever you're doing stream processing that fault tolerance and HA is fully built into the architecture, and that's what we have. So here, node 24, it's on container number 7. I'm going to go ahead and kill this bad boy here. And the kill's been sent. Here, you're going to see that now we're pending. And a new node here, node 4, has already been requested and set up. It's now, in fact, it's already processed. Here, the processing of events kind of spiked up to about 11,000, 12,000 events per second. You see the graph here. There's a brief spike in the amount of processing as it caught up from the last checkpointed state, and we're back now down to steady state again. So really just an example of how really seamlessly the platform works. And our whole approach to this is we want customers to really focus on their business logic, on what's most critical to their business, and all the plumbing underneath, all the scaling, all of the fault tolerance. That stuff should be taken care of by us, and that's what we specialize in, and that's what we offer. We also do what we call auto-scaling, so that a customer can, in fact, if they have a certain time of day where activity spikes up quite a bit, then we can actually adjust to that and ask for more resources to deal with the added load. And then when that load goes back down, we can then release resources back to the Hadoop cluster, again, being kind of a good citizen in that regard, as we're a multi-tenant your own application. And so really, and those are thresholds that a customer can set, above threshold and a minimum threshold. So we really, all that plumbing is something that we can take care of. Customers can do things like A/B testing of their applications and run those applications without having to restart them, make changes on the fly. So truly a very kind of a flexible platform that really gives a lot of power to the customer at the end of the day, power that they really haven't been able to use before this. And that's our demo.
Wow, that is really, really cool stuff. And so basically what you've got here is the foundation for building, you could call them quite sincerely, I suppose, next generation applications that fully leverage the power of Hadoop, right? And it could be really anything you need, but you guys are focusing on that really high intensity environment of tremendous amounts of traffic, very serious business needs, and that's obviously where the money's going to come from in the near term. But this has far-reaching implications, right?
Yeah, absolutely. We do see Hadoop, especially with Hadoop 2.0, as sort of the de facto operating system for distributed computing. We think that more and more companies, enterprises are going to be dealing with data that's going to be gargantuan in size. It's only going to get bigger, and really for those kinds of use cases, they're going to need to leverage a cluster of machines. And as they do that, technologies such as Hadoop and DataTorrent are going to really give them that power to be able to do that, so that they don't have to wait days to get results, but now they can literally get information and get insight, sub-second, right? Which is going to be critical when they are trying to analyze data and really kind of compete in the modern business age.
That's great stuff, folks. Well, this is wonderful. We've been talking to Henry Sohn of DataTorrent. Great job, guys. This is very, very cool stuff. Thanks a lot.
Thank you. Thank you.
All right, folks, we'll catch up to you next time. This has been the Inside Analysis Big Data Ecosystem Market Overview. Talk to you soon. Bye-bye.